This is it.
All right, thank you. Yes, let's see how well I can resist the jet lag. But first I want to praise Oliver for having a brilliant idea to make an Oxford Handbook volume on a problem that doesn't have a logical solution. But there was precedent before, and I think it is a method similarly used by, or maybe even invented, by Thomas Aquinas, who likewise faced a problem that couldn't have a logical solution, the problem how to explain immortality of soul from Aristotelian physics. And his solution was to write a book more than 1,000 pages long, very heavy, very sophisticated, very intimidating, and very erudite, and explore it from different. So, and after he read this book, everybody was intimidated because in order to approach the problem, you first have to read this book. And so effectively, it was not a logical solution to the problem, but it was an effective solution to the problem. So I think in our case, we also, maybe this book is our best chance that will be the new dogma for the next century. and proceed. And that was the introduction. Now, historiography. So yes, my paper in this volume was historiographic, which means a meta argument, meaning that there are physicists who are concerned with the reality of the world, the strange ways of the world operating, spaces of different, many dimensions. Then there comes historians. Historians are concerned with the reality of physicists and the strange way physicists operate in the space with many dimensions. Some dimensions might be intellectual, some are financial, some are political, some are sexual, and any others. And then comes somebody like me who writes a historiography, which means being concerned with the reality of historians and their strange ways of operating. And so in some sense, what I was doing here is that maybe I summarized by a title borrowed from Massimiliano's paper, sort of what have historians of physics done to us, and also to quantum interpretation, because they also had an impact on quantum interpretation. The professional historiography of quantum physics more or less started, I was born in the beginning of 1960s. At the time when quantum mechanics itself, or the quantum community, was considered done. So it was developed, finished, interpreted, and understood, not even interpreted, and closed. And from this point of view, from point of physicists, there was not that much of a debate, but there was a feeling from the physicists that they have done, in the previous generation, they've done something very exciting, very fundamentally important. And also that was a time when physicists were at the height of their Cold War power and financial prosperity and had money. And they saw the warning bells when, or heard them, when Einstein, Schrödinger, and Pauli died around the years around 1955. But some of the founding fathers were still alive. Niels Bohr, Heisenberg, Max Born, Dirac, and others. And at that point, the physicists decided to use some of their money to sponsor a project to record interviews with these people, with the still living founding fathers of quantum mechanics. And that became the beginning of the start of the project. They became known as the Archive for History of Quantum Physics. And also a pioneering attempt in history of science in general to practice oral history in the massive scale. Because I am not aware that in history of science that has been done before. So in this sense, quantum historians at the time were at the forefront of methodological innovation in history of science with large. And this created a project which for the dimensions of history of science was a big science dimensions. For 3 years, Kuhn and his small group of collaborators, mostly two graduate students, Handbook and Forman, and some bibliographical assistants, recorded over 100 very detailed, very intense oral history interviews. And so, how intense they were is illustrated by the pontifical story that is circulating in our small community, that Kuhn actually killed Niels Bohr. Because his interviewing was so intense and stressful that Bohr died the following day. Whether true or not, but this is a story about that observations by historians can also have some uncontrollable experimental effects. And that we should be careful about. So yes, and about Kuhn, I kind of write here as a historian, not another philosopher, but we'll probably deal with this later. Now sorry. It also created, but even more than oral history interviews, he also recorded and photographed, microfilmed more than 100,000 of pages of documents, of correspondence, kind of manuscripts of the founding, and that from later historian was even kind of a great of an answer, because oral history in the end proved less usable, but correspondence definitely was. And since then, this archive of history of Forman Thesis became a goldmine. Essentially, everyone who is working in the field kind of has to use that, and nobody has a capacity to read all of it. So that has been kind of the foundation of kind of everything that has been done since that time. There were several distinct methodological approaches used. The first one, we can call it sort of an intellectual approach writ large, basically compatible with Kuhn's book, Structure of the Society of Evolution, because the details of that correspondence were so rich that it created a hope or maybe illusion that historians can follow sort of a documentary how ideas were being born, and follow the ideas approach, and try to dissect the generation of the new ideas. So just because of the intensity of the sheer value of the sheer amount of the information and the then came the so-called disciplinary approach, or disciplinary institutional approach, because these historians who were working at that were also operating in the 1960s, when on the one hand science became big, and it was clear that scientific practice depended on money, personnel, and the numbers, and that was the post-Sputnik era. And that awareness also translated back into history. They start asking questions about who funded the research, how many jobs there were, and essentially follow the money approach approximately. And when translated back into that history, and that reminisces of the awareness of the time. And it also of the time they started asking questions about physicists and ideology, because if in the previous generations scientists could be thought or imagined as seekers of independent truth, in the 1960s era they were very often seen as people corrupted by military-industrial complex and following ideological agenda part of the establishment. It's also a raised question about the the possible ideological agendas of physicists at the time. Now the community, the sheer number of it. I once calculated, so I tried to calculate, how many authors actually contributed to quantum mechanics. I only managed the first year and a half, basically, from first Heisenberg paper to his uncertainty relations paper. Then it was get exponentially high, so I lost count. So up until that point, I calculated approximately 80 authors, approximately 200 papers, plus some books, and I think 15 different countries, roughly, in the first year and a half. So two observations about that group. So the first its dynamics definitely different from, let's say, relativity theory, just by the numbers, sheer numbers of people who contributed to that, and the whole group. The second observation is the young age. Many of them were very useful. Essentially, the majority were postdocs or maybe graduate students at the last years of their work, or generally, let's say, postdocs. And this is the photograph that I usually use to illustrate that thesis. It looks like a normal photo, people traveling to Stockholm to collect the Nobel Prizes. But once you apply gender analysis to it, you understand that there's something strange about it. According to the gender protocol of the time, the prize winners arrived in Stockholm with their spouses to participate in the ceremonies. But in that case, two of the participants didn't have spouses. And not only they were not married, they didn't have a girlfriend, and probably were still virgin at the age of 30. So what happens when a Nobel Prize winner is socially and sexually mature? He is chaperoned to Stockholm by his mother. And this is what happened to Dirac and Heisenberg at this point. So the photo shows that two of them, Dirac's mother and Heisenberg's mother, become the Nobel Prizes and just observing the boys during that. They just to illustrate the distinctness of that community. And another thing also within that community of roughly up to 100 people, it relates to the pluralism of interpretation, because debate about, it wasn't yet called interpretation, it was called philosophical lessons. All this started before the theory was completed. There was so much competition and intensity that not all of this 80, but roughly about, let's say, half a dozen or dozen of them felt significant enough, important enough, to start arguing with each other about philosophical ideas of that, even before the quantum mechanics was more or less finished. So in that case, the debate started even back at the time. Now, the next methodological approach what turned in that group on top of the archive of the history of quantum physics, we can see database of big data, was the famous thesis by Paul Forman on environment culture and quantum causality that I will summarize. Here. This is first, it's not just one paper, but it's an argument that developed in a series of papers, and with some a little bit different additions and interpretations, in addition to the one of the most famous one of 1971. And this is the summary, my summary of these papers together. So, sorry, I apologize to those who already know this, of course, very well, but I try to do it shortly. So the Forman thesis is, it might be not just one thesis, but an argument or a series of claims, series of theses that form a logical sequence. It starts with observation about the state, ideological state of German-speaking society, not just in Germany, but in the German-speaking world, after the defeat in World War I, which was characterized as overwhelming crisis in all different domains. It was crisis political, it was crisis economical, and with several consecutive meltdowns, financial. So the loss of the empire, the loss of the military might, and the situation when science remained the only, what in German is called Machtersatz, for the only remaining strength in the German world, where they could compete with others. But and also the loss of prestigious, secure social position that academic used to have in the imperial world. So for the German academics, it actually meant that, contrary to today's stereotype, where people usually thought of university professors as being somewhat political on the left, in the post-World War I German situation, it was the opposite. The German academic world generally tended to be on the right of the existing, let's say, political establishment, so to say, right? And having nostalgia, being nostalgic about the imperial past, but also critical about some of the previous values. So the next, sorry, just before I go to that, so this general perception of overwhelming crisis also was added, had an added discourse on crisis in science. It was fashionable and common to talk about crisis in science that was also overwhelming, not just in one particular discipline, not only physics, but and also concerning the science as an activity for business in general. So that's the first part. Second is the values. In that a trauma of the defeat of World War I, the German middle class and the German-speaking middle class and academic community also became somewhat critical about the pre-war values that were at that time associated with the optimistic belief in progress, or maybe naive belief in progress, in technology, in rationality, and in science. So it was somehow perceived that it was overstated belief in those values led Germany to fail us in the war. And instead, the society, so other ideas became fashionable. Ideas that were more romantic, more conservative, more irrational, associated with the philosophy of life at the time. And then Forman looked at how the community of exact sciences reacted to these general ideological changes. And his perception was that kind of so generally kind of from these dominant new values, science seemed to be, at least exact sciences, seemed to be under attack, kind of a critic, because kind of the theoretical physics in particular stood for kind of a previous value of rationality, abstraction, and causality, and those became bad words in the discourse of the time. So Forman anticipated or thought that the community of physicists would react to this pressure from the outside society with some kind of a defensive way, but he actually found out that they adopted, or at least embraced some of that value, and that even before the quantum mechanics was completed in 1925, several prominent members of the mathematicians and theoretical physicists in German-speaking world started talking about such a development of causality principle, or kind of so in this sense causality kind of was, they were ready to compromise with causality even kind of before 1925. And when in 1925 quantum mechanics was invented, that idea was gladly attached to the quantum mechanics as a new theory that actually scientifically proved that causality principle was no longer valid. It's not in its strict kind of deterministic version that before. And that kind of summary of the Forman approach is that he sort of contrasts what he thought. So quantum mechanics was a statistical theory, but in the existing situation, sort of a new philosophical value was attached to it, which kind of claimed more than just statistical, claimed kind of having proven that causality principle was wrong. Quantum mechanics was an abstract, hard to understand theory and hard to visualize, but the prevailing ideological principle actually wanted or pushed the scientists to declare it's actually visualizable, or anschaulich in the German case. So anschaulich was about, causal was a negative word, anschaulich was a kind of was a positive word, and again sort of what was in the quantum mechanics, how they dealt with the kind of theory of mathematics, had to attach the label visual to it there. And in the theory, kind of, there was a loss of individuality of atomic particles, but once again, kind of the prevailing philosophy required from physicists, including Niels Bohr, to proclaim that actually in the concept of the quantum, the theory also proclaimed the individuality, kind of, or some kind of unbreakable individuality of microscopic events. So this is kind of the Forman thesis. There is a document. How am I doing with time? So I found one document which kind of almost literally supports Forman's thesis and shows that kind of a science at the time were actually aware kind of what was in demand for them. And this is a letter of 1919 from Paul Ehrenfest to Niels Bohr, which actually describes, and Ehrenfest actually describes student body, and professors have to care about what the students know. And it described it saying that now kind of we have a new generation of students who embrace irrational ways of thought, and if you're like me, Ehrenfest was talking about like an old-fashioned rational guy, you will not be popular among students. And if you want to be popular among students, you need to sound somewhat mystical, somewhat warm up kind of personally, and and to be hard to understand. And this is a description which very much fitted Niels Bohr, kind of what Niels Bohr was doing at the time. And Niels Bohr was notoriously hard to understand, and he was more or less willing to use the word mystical kind of when talking about quantum ideas in this sense. Okay, so I'll probably skip this point. I'll maybe just kind of one thing about that. Sort of when Forman Thesis was published around 1970, it met with very strong, you can say, scandalous resistance. Of course, kind of one can imagine the physicists didn't necessarily like it because at the time, by the standards of the time, causality was something that was not just considered to be philosophical interpretation attached to the theory, it was considered to be the core lesson of the quantum mechanics and so Forman criticism of this what he called capitulation of German physicists to the anti-rationalist ideology of the time, and was seen as kind of as attack on the core of quantum mechanics itself. It was also fell hard on both sides of the, at that time existing very strong Cold War polarity within the history of science community. The history of science community at that time, methodologically, was polemically divided between so-called internalists and so-called externalists, which in practice stood for Marxists and anti-Marxists. So that avoid using the word Marxist, they were called externalists and internalists. So internalists didn't like Paul Forman's work because for them it sounded like the subversive Marxism, or similarly kind of external criticism. Externalists or Marxists didn't like Paul Forman's work because from the Marxist point of view, bad philosophy could corrupt science. But in that case, paradoxically, a reactionary, anti-rationalist kind of a German philosophy actually helped to do something very important in science, it had some kind of like at least heuristically. So this is neither the old left nor the Cold War anti-communist kind of a part, were found much to like in that form. Now the next I'm switching a little bit the logic here is other part of how some of these topics were perceived by a different order, by not by the professors, but by young physicists who at that time were starting their careers, composed of the mass of the practitioners as quantum mechanics. My point here is that we need to, when we talk about people like Pauli, we need to understand that precarity was not just the function of today's world, academic world. It also very much the difficulty of starting academic careers in interwar period. So no matter whether Pauli was eventually a great career, Nobel Prize, but still at the time being, when he was working on quantum mechanics, he was penniless, without a job prospect, and without knowing what will happen to him professionally the following year. So, and that was that feeling is very important also to understand what his choices, and his solutions when he was basically contributing to quantum mechanics. In 1923, so first he was from Austria. In Austria, things collapsed much stronger than in Germany. And so basically, more or less, in Germany's scientific activity continued. In Austria, it's pretty much destroyed by and inflation happens. The hyperinflation happened here earlier. So Pauli, as a young student, escaped Austria and came to study in Germany, where things were still academically good. But then hyperinflation caught with him there too. And in 1923, when he first got an invitation to come to Copenhagen from Hamburg, he couldn't even pay for a train ticket. And Hamburg to Copenhagen is not a very long distance. So he had to, because the German mark collapsed completely just right at that time, end of 1922. So he had to ask Bohr to buy him Danish kroners from Copenhagen, so he can actually pay for the train ticket. When in Copenhagen, and then he was coming back and forth between Hamburg and Copenhagen, the lady here received an invitation from Sommerfeld to become Privatdozent in München. And he, after some thought, he rejects it. Basically understanding that he, at least for the time being, he would be better off if he had some temporary position in Copenhagen, just a little funding to stay. Because in the German situation, Privatdozent couldn't survive financially. He knows that it would not do anything for him in the long term because there's no permanent jobs in Denmark. But at least for the time being, as a temporary, something that you can survive for a year or two, with that thing. And he writes his rejection to Sommerfeld, essentially more or less comparing his situation with quantum unpredictable particles. He's basically telling, but for the time being, I will be in Copenhagen. I know there is no nothing long term here. Eventually, I will have to look for a position somewhere else. But what would happen to me a year after, I know as little as electron knows where it will jump in a fraction of a second. So this is the quantum causality or unpredictability of microsecond was also existential perception of those physicists there. And I started calling them quasi-free postdocs. Maybe the better formulation is virtually free postdocs. Because there were people who survived on soft money, on very unstable money, very, very short term. And in order to get this money, they also had to move from one place to another. And just by the very fact of their moving, to some degree, partially, made them free from their professors. Because in the traditional pre-quantum academic trajectory, these people would be doing the job for their professors, basically following their orders and their programs. in that situation, kind of when they actually were switching positions kind of from one place to another, there was a possibility for people like Paul and Heisenberg, who were intellectually mature but socially still unemancipated, to acquire a certain window of freedom, and which was important, for example, for Heisenberg when he essentially escaped both Copenhagen and Göttingen for his, I think, 2-week stay in Helgoland to write his, so in order to write his seminal paper that started quantum mechanics, I kind of argued it was important for him to actually be able to get away kind of outside, because neither Bohr nor Born kind of was working in that direction, and Heisenberg kind of had to write kind of to follow his own ideas, to suggest some kind of different radical ideas here, and then trying to sell them to his professors, kind of trying to find which of his professors would actually agree to send his paper to the journal. Because kind of the people like Heisenberg at the time still needed permission from their professors to actually send paper for publication. So kind of a virtually free postdocs. The triumph of the postdocs came in the year 1927, when there was simply so many of them assembled in Copenhagen that Bohr couldn't keep track of them. And for the moment, in some sense, we can say that quantum mechanics is a moment when just a group of postdocs were carried away with their own kind of a collective work and kind of stopped paying attention to the and professors actually had to catch up and had to do something kind of with the catch up. I called that phenomenon the revolt of the postdoc, and I was immediately criticized because what kind of revolt it was. And then I have to say, well, if you look at it from the French position, then of course it's not, because the French people know how to rebel, and they know how to make riots, as we kind of all know. But from the German position, I guess, I mean, in our normal language, it would probably be considered slight insubordination, but by existing German patterns, that was actually a revolt. And it wouldn't count as a revolt, but from people who know what French Revolution was. But with the existing Germanic culture, kind of it was quite. I think that was my last slide. I already said about critique of the Forman Thesis. Now, since Jean-Phil wanted me to tell about this, just as an illustration how different values were attached to the same quantum mechanics, we can move from the conservative German ideological climate into the revolutionary Soviet ideological climate. And then we also have kind of physicists who are trying to adapt or explain the existing quantum mechanics to the prevalent values, political and political values of the time. And this is kind of the different triad compared to the polar difference to the choice of the German colleagues. So from the point of view of doyen of Soviet physics, Abravyov at the time, who basically tried to explain to Soviet Marxists what quantum mechanics was. So he was very upset. Quantum mechanics is not visual. That was very important. So the Germans would want to have it anschaulich. And in Russian, it was the very opposite. It was not visual, it was very unintuitive, and that was in some sense the proof of its revolutionary radicalism. So that was a positive thing. The second thing you would see the statistical adaptive is still causal, and it was important. So they would never compromise on causality. So for them it was important to still claim that it's a causal theory, even if it uses statistical approach, they were arguing that there's no kind of a constant contradiction. And finally, they were very proud to say that in quantum microscopic world, kind of actually individuality loses its meaning, and we can talk about kind of collective. So this is how kind of a Soviet values were kind of attached to pretty much kind of the same quantities. And the last word about kind of the Forman approach and thesis. So as I said, it was initially introduced very negatively, and for years and decades, we can say kind of the label controversial was attached to it, which in my view is very strange. Because in a certain sense, which at the time seemed radical innovation, that the thesis that social and cultural values actually matter for the work of physicists. Nowadays, it's completely uncontroversial. It's our historians of science bread and butter. We all use that. Without creating it, it's kind of the Forman pioneering work. So in that sense, I compare Forman to Schrödinger, in the sense that kind of everybody in quantum world used Schrödinger equation. and yet Schrödinger's reputation was somewhat problematic kind of within the quantum, because somehow he didn't control the problem interpretation. So in practice, kind of we're all following Forman kind of in that case. But in rhetoric, it's still kind of the habit to criticize, to find something controversial in his approach, kind of, which in my view is kind of at least the most important innovation kind of that is actually kind of fully accepted. And in this sense, I think he compares to Kuhn, because it's a habit to praise Kuhn, even though nobody now continues to use his philosophy to kind of explain, kind of, at least to explain this historical. And in Forman is the opposite. Kind of, it's still the habit to criticize Forman, but even though we all kind of, almost all of us kind of use some of the kind of approaches that we use there. Thank you.
Question? Yes, Sebastian? I don't have any.
Yeah, thanks so much for the talk. I wanted to ask you, well, actually related to this. So, as you know, later there is the Strong program in Edinburgh, and I was wondering if they kind of got inspired.
That's been cited, yes. As one of, basically, for them it was one of the strongest cases. Especially because it's from their point of view, it was the only case they could cite that goes to the bottom of science, sort of, kind of to the core of science. Many of the other cases for the Strong program were kind of more peripheral, but in that case, kind of, they definitely cite this as a very important case. And also, I forgot to mention that Forman analysis was important for John Bell as an additional inspiration for him, kind of, and Forman, Bell also cited Forman kind of, in that sense. So in this sense, kind of a Forman book is one of those when critical analysis by historian can actually contribute something to the critical analysis of physicists. Kind of like Marx's analysis of the problem of Newtonian mechanics kind of was important kind of for Einstein kind of in that case kind of Forman critical analysis of quantum philosophy kind of, was helpful at least for John Bell as an additional argument.
Can I jump in there? I've heard the story that Forman was partly inspired to write the paper because he heard of bone. Have you heard that, Alexei? And can you add anything to it?
I didn't find anything in the documents, let's put it that way. So he was definitely inspired. Basically, Forman is very kind of open what his sympathies are. He's very moralistic in that case. Yeah. He basically says, "I'm with Einstein and Schrödinger in their defense of rationality, and I'm against the so-called progressivists who actually denigrate rationality on that." So he's definitely, at least he was definitely inspired by Einstein and Schrödinger. That's for sure. Whether he actually kind of followed the kind of the 1960s.
His language of capitulation.
Yeah.
One last question from David. Thank you.
Alexei, thank you. That was really fascinating. So just two quick things to toss out, and we can all discuss soon over here. Number one is, as I'm sure you know and others may know, Kuhn's book, Structure of Scientific Revolutions, came out while Kuhn physically was in Copenhagen, still immersed full time, about to kill Niels Bohr, but immersed in those oral histories. Yeah. And so the immediate response, in fact, for months after Structure came out, Kuhn couldn't respond very quickly because he was waiting for mail to be shipped from Berkeley to Copenhagen. So there was a huge, many months delay in response to Structure because of AHQP. That's just something about where Kuhn was physically and what it was like to have to work internationally at the time. The second comment was about Forman's thesis. The part that has resonated with me most of all, and I'm curious, I wasn't sure where it showed up in your typology, if you agree, was it wasn't merely, we might say, sociological, and it wasn't only about the kind of atmospherics and miasma of, Spenglerian Leibniz philosophy. I really thought he lays out where the gears would mesh. It's a highly institutional story in the middle of the 115-page article, by which I mean, the rectors of the powerful German universities were coming from humanistic fields like philology. These young physicists had never been in charge. They were losing their status together, and they had to face these hostile audiences not in an abstract or metaphorical way. They had to face, essentially their deans in these public Leben when they got their jobs and promotions. There was a place where they met, and they had to answer for themselves. And I found that really fascinating.
That's where the most, basically, the most common opportunity for these German-speaking physicists to address topics of general interest were university assemblies.
Because they were
They
required.
actually, they all had to somehow translate their work,
Yeah.
so it would be somewhat unintelligible, not necessarily to the deans, but also to colleagues in kind of a university council, kind of all other professors in all fields, kind of including humanities. And the common language, of course, is philosophical. Kind of. So they would have to somehow make a sense of whatever their sophisticated technical work, kind of to, and that would be kind of for them. Indeed, kind of almost every inspiring academic would go through this purgatory, we can say. And yes, kind of, they have to kind of find the words in order to appeal to that audience. But I think when Aaron first mentioned students, I think actually they face student audience much more often than this. So in that case, kind of, I think there's additional audience here, kind of, that, and my feeling is that maybe professors actually care more about students, in some sense, kind of, than just their colleagues in philosophy or kind of, or in the humanities department. But of course, as a source, as a printed source, yes, kind of, the main thing is kind of when a German a newly appointed professor would come to the general meeting of the university council, meaning all other professors, and basically try to explain to them what is it happening in their field.
We move on to the next. Thank Alexei again.